Welcome to Allstate, where the safer you drive, the more you save.
Like a glove.
I'm Jimmy Dean, and
ain't that nice?
Tama yun, kutsura eh. Welcome back. Another day of stream. Subscribe, comment, drop a like if you haven't. Today, let's continue with our adaptive layouts. We did the only collab in this path. What's it called? Path line. And since we did the lunch tray app already, we will do the reading and the quiz. Let's go. Expanded ecosystem of device form factors. Ranges from iPod to iPhone to tablet to computer to watches. A seamless user experience when transitioning from one device to another. Even orientation and aspect ratio should be flexible. Can it be the name of it? Breakpoints and window size classes. Of layouts user with 3 points described earlier. This stuff is image parents. You want us to share data? Monica layout, Fate Hero. Consider using a flexible, different layout manager, grid layout manager, staggered grid layout manager, or flex box layout manager. This one's leaning one after one. This one has grid stem, not necessarily matching. Highlight an element. Wait, but isn't that the minimum size you want to show those at? And as the screen gets larger, it gets smaller. The higher the percentage. The closer it is to the minimum size. I don't know how you would determine what percentage you would use that hero for. Like half the screen or full screen. Screen becomes a grayed out, floating down look. It takes the same emphasis. Supporting panel. Nice detail view. There's not enough room. Detail sites aren't enough. Okay, let's do the quiz. It's already finished. Check the earlier videos. List detail. In most cases, the pane will only sign on small devices such as without evidence. Sure, that makes sense. Compared with typically find this 600 720. Can't remember this one. There's some ratio. It's not aspect ratio. This is true on smaller devices. I can't remember this. So changed. Go back 600. Layout weight. Press callback. Handle back pressed. This is always this function. Slide over clicks. Really? I know I only have 1 and 3, but yeah. Cool. That's the quiz. That would be the recording. See you next video. Mm. Wait, this is older, really? Man, this stuff updates real fast. Oh. So don't have to fit in XML for the layouts. Effect. Effect. That's a typo. Oh, really? A year ago?
To whom it may concern, I'm applying for the position of Information Security Analyst. I've always
Hello there and welcome back to my new video. In this video I want to introduce you with Jetpack Compose. So at the time of recording this video, Jetpack Compose is still in beta, and I think that now it's the right time to get introduced with it. Now before I continue, I just want to tell you that XML is actually not yet deprecated, so you don't have to worry about that, and you can still build Android apps using fragments and XML, or even combine that with Jetpack Compose until you are confident enough to switch and develop your apps using Jetpack Compose only. Now, Jetpack Compose is a modern toolkit designed to simplify UI development, and it combines a reactive programming model with the power of Kotlin programming language. It's fully declarative, meaning that you describe your UI by calling a series of functions that transform data into a UI hierarchy. And when the underlying data changes, the framework automatically recalls these functions, updating the view hierarchy for you. So what does all of that actually mean in practice? Well, it means that from now on, if you want to build your app with Jetpack Compose, you are not going to need any XML files for declaring your UI content. Instead, you will build your UI by writing composable functions. And the composable functions are just regular functions marked with a composable annotation. And this annotation will tell the Compose to add a special support to the function for updating and maintaining your UI over time. So Jetpack Compose also supports MVVM out of the box, which means that now it will be a lot easier for us to organize our code into small chunks. Plus, composable functions are highly reusable, which means that we can create complex UI elements and just simply reuse them in other places, or share them with an open source community where other people can easily integrate those elements into their projects without a problem. And now let me show you one simple example of how we can declare a text, formerly known as a text view, into our application using Jetpack Compose. So this text is a composable function which comes as a predefined function with a library, and here you can see that we have declared just a simple function with a composable annotation. And now some of you might have noticed that the first letter of this function is actually an uppercase letter. If you try to write a composable function without the first uppercase letter, then you'll get a warning from Android Studio which will say something like composable functions that return unit should start with the uppercase letter. So that's kind of a new rule which you should start using with composable functions. And now, since we are not using XML files to declare our UI, you might be wondering how can we even see or preview our UI with the composable functions when there is no layout editor? Well, there is a solution for that as well. So in Android Studio, when we open some Kotlin file, for example, there is a button on the right top corner that says split, and we can preview our UI by opening that up, but still there is just one more additional step. So we need to write another composable function, but this time with one extra annotation, preview, and inside that new function we would just call our first composable function, and then we would be able to see our UI on the screen. Now the main entry point for composable functions is activity, as you might already know. So you can use set content to define your layout, but instead of using an XML file as you would normally do in the traditional view system, you would call a composable functions inside it. So in this example here you see only one text, but if we try to add one more, for example, then those two texts would overlap, and that's because we haven't specified anything related to their arrangement in the content view. Now, there are two main predefined composables, which will allow us to display a collection of composables in a formatted way. And those two are row and column. Row will align all its elements horizontally, while column will align all its elements vertically. So rows and columns are basically similar to the linear layout which we have inside our view system. And if you want to avoid the compose overlapping, you would just define composable functions inside one of them, like in this example right here. Now I'm going to explain more about rows and columns in some of the future videos. For now, it's enough for you to know that you should always put your composables inside one of them. Also, there is a third option called the box, and it's kind of similar to the frame layout which we have in our view system. So there are more interesting and important concepts which I want to cover in some of the future videos, because I don't want to confuse you with all those information right from the start. But before I end this video, I just want to mention one more thing, and that is a life cycle of our composables. So to understand the life cycle of composables, first you need to get introduced with the concepts of initial composition and recomposition. When Jetpack Compose runs your composables for the first time, during initial composition, it will keep track of the composables that you call to describe your UI in a composition. Then when the state of your app changes, Jetpack Compose will schedule a recomposition. And recomposition is when Jetpack Compose re-executes the composable functions that may have changed in response to a state changes, and then updates the composition to reflect those changes. So I'm going to make a separate video about states in Jetpack Compose, because there are more things to cover. Anyway, the life cycle of a composable is represented through 3 different steps. The first one is entering the composition, the second one is getting recomposed 0 or more times, and the third one is leaving the composition. So a life cycle of one composable is simpler and smaller than a life cycle of views, activities and fragments. So when a composable needs to manage or interact with external resources that do have a more complex life cycle, then you should always use something called effects. And I'm going to also cover effects in some of the future videos. So for now, that would be all. This was just a little brief introduction video about Jetpack Compose. Row will align your thing, and that is a life cycle like this video.
The current view system, except not use XML. Anyway, this is stream for the day. Thanks for watching.